the first sunny day of the week, and it's fun to get out and ride. Of course, it's always more fun if John and Bill come along. But not today. John has a new camera, and he's been waiting for the sun to come out, too. And Bill, well, he's going to have his picture taken. That is, he thought he was. But that's no camera. Fact is, Bill's never seen one of these before. So John explains that this is his father's light meter. This little needle shows how much light there is. His father told him that if the needle pointed between 1 and 200, there would be enough light for a picture using his camera and film. The meter will be very helpful to John. It will show him when there is enough light to take a picture and when there is not enough light to take a picture. Bill had never thought about that before, about light and how different it can be, from the shade all the way to the brightness of the sun itself. There. That ought to be a good shot. But wait a minute. If that light meter shows you when there's enough light to take a picture, let's see if we can take a picture inside. Bill's hobby is tropical fish. He's very proud of them, and he thinks they'd be great for pictures, even better than he was. Say, they are beautiful, aren't they? John likes this idea. He's ready for action. This ought to be easy. But now, wait a minute. John has a problem. There's less light in the room than he thought. Nope. It looked bright enough, but the meter shows there's not enough light for his camera. Well, maybe they can find some things that'll help to give more light. How about some candles? People used to use candles for light before electric lamps were invented. Fact is, when the power fails, candles are still used once in a while. So let's measure the candle light. No, the candle just doesn't give enough light. This lamp is much brighter. But look, light won't pass through the metal shade. We call such material opaque. Hey, there's one that's better. Some of the light comes through that shade. That material is translucent, but there's still not enough light. Well, there's a chandelier, and it's transparent. It lets all the light come through. But that won't work, says John. The light is too far away from the fish. Here's another lamp, and if you turn it up like this, it's pretty bright. Well, let's see what the meter shows. Not bright enough. But as the lamp is moved closer, it seems much brighter to John, and the meter shows that it is. So the next thing to do is move the light in close to the subject. John now has enough light to take a good picture. But where's Bill? Bill's going to make sure they have plenty of light. Here's another lamp they can use. Just plug it in, turn it on. Now for that picture. But John seems to have another problem. The new light will show right in the middle of the picture. Instead of all the light passing through the glass, some of the light is bouncing back to their eyes. It's being reflected. But the boys soon find out that if they move the lamp, the reflection moves. So if they raise the lamp, they're able to raise the reflected image of the bulb up out of the picture. Now John can take his snapshot. There, that does it. John is satisfied. But not Bill. Bill's not thinking about pictures anymore. He's trying to figure out what happened when they had trouble with the reflection. Bill's curiosity helps him to learn. He finds that he can block off the reflection. He also notices that this happens only along a line from the lamp to the glass and along a line from the glass to his eye. Bill is finding out that light travels in straight lines. Move the source, and the reflection moves as well. Now let's see, what else can we learn about reflection? Do other things reflect light in the same way? A mirror gives a very good reflection, doesn't it? Let's see how good. Bill finds that by shining a flashlight in the mirror, he can get a very good reflection, even on the other side of the room. And the light still travels in straight lines. So the mirror is a good reflector because of its smooth, shiny surface. Smooth, polished metal like this picture makes a good reflector too. But because of its curved surface, it does funny things to Bill's face, doesn't it? What about the top of this table? How does it compare with the picture and the mirror? Not so good, is it? And yet it does reflect some light. Without the reflection of light, we would not see the things around us. Here's an experiment to help show that this is true. How much of John's face we see depends on how much light falls on it. This light is reflected back to our eyes. We see the fish in the tank because they reflect light too. But now, looking down into the tank, John sees something unusual. The thermometer looks as if it's broken. No, it isn't broken, is it? It just looks that way. Do you suppose light has something to do with this? Yes, it certainly does. And with the help of Bill's flashlight, perhaps we can understand why. In a darkened room, we can see how light bends as it goes through the surface of the water. We call this bending refraction. Now do you see why the thermometer appears to be broken? The light that is reflected from the part under the water bends as it comes out of the tank. Refraction can be very useful to us. The magnifying glass bends light to make what we see look larger. The light that enters a telescope bends to make faraway things seem nearer. Some lenses bend light to sharpen sight for eyes that need help. Other lenses help us take pictures. But of all lenses, the most important to us are the lenses in our eyes. We've used them to discover many things about light. That the sun is our greatest natural source of light. It is far brighter than the artificial light we use inside our homes. We have also discovered that the closer we are to a source of light, the brighter it is. Some materials are transparent, allowing all the light to go through. Others are translucent, allowing part of the light to go through. Still others are opaque, allowing none of the light to go through. Sometimes light can cause problems of reflection, as it did for John. But reflection is of the greatest importance. We see almost everything by reflected light. Without it here, we would see only this. We have also seen how light bends as it passes through certain materials. The lens of a camera causes the light to bend onto the film. And speaking of film, how about those pictures? Say they're good pictures. And they'll help the boys remember what they learned about reflection and refraction, especially the one Bill's looking at now. Bill thinks this one deserves a title. This is Bill, beginning to see the light.